In this video, we're going to do a very crude experiment where we're going to measure the resistivity of a liquid versus voltage. And so what I've done here is I've set up basically we have our 9103, which is set up to float on a high voltage supply. And then we have two electrodes. One electrode is for the signal path, which the 9103 is floating on the high voltage. And the other end is basically ground, which is connected on the back of the supply, which completes the circuit. So this is our electrode setup, and what I have is basically just a piece of glass with a little circle around it, and then two electrodes that are going to touch the liquid. So what I'm going to do is I'm going to use an eyedropper here, and we're going to fill it up, and we're going to drop in just into the center here. I'm going to try to make it come out to the circle as much as possible. But at least we have a little bit of a control in the circle. Okay, so now what we're going to do is we're going to manually increase the voltage on our voltage source, float the 9103 up, and measure the current that's going through our liquid, and then graphing that on the 9103 software. So let's increase the voltage here. There's 10 volts, 20 volts, 30 volts, 40. Okay, I'll take it up to 100 volts. It's about 70 microamps. Let's drop this back down to 0, go up to 100 volts offset. Now we'll keep increasing this up. Okay, there we've got about 150 microamps. Let me drop this down. Okay, let me pop it up in 100 volt increments. There's 250, 350, and we're over range now because we hard-coded the 200 microamp range, so I'll drop this back down. So we don't want to go over 200 microamps in our test. Let me bring this back up a little bit, the voltage. Okay, that's pretty close. That gives us 253 volts, gives us about 200 microamps of current. And so with that information, we can calculate the resistance of the tap water test that we just did. Okay, now we're going to repeat the experiment, but this time we're going to do it with distilled water. So I'll start increasing my power supply, and here I can see there's 100 volts, 100 volts again, 200 volts, 300 volts, 400 volts, and that's just a little too much. Let me drop this back. So to get the same 200 microamps of current, we're getting that now with 430 volts. So we can see with this experiment that the resistivity of distilled water is much higher than that of regular tap water. So again, since we have to crank this up manually, this is one of the reasons we're developing our new programmable power supply that will work seamlessly with the 9103 picoammeter.